Good morning to all. In last session, we discussed about the worm and worm wheel, the terminology used in a worm and worm wheel, and how the force or a torque are acting on a worm and worm wheel. So in today's session, we discuss the numericals on a worm and worm wheel. There is one question which is asked in a university exam. I have taken this and we will solve this. Before that, we first of all discuss the formulas which are used or we required for solving the numericals. Okay. First of all, we discuss this formula, list of formulae for a worm and worm wheel. The first formula for helix angle, or it is also called as the spiral angle. Here, the alpha W is the spiral angle. Worm and worm wheel is the one type of the spiral gear. So we can use both helix angle or spiral angle. The alpha suffix W is helix angle for a worm. We all know that the worm is the screw type part and worm wheel is the, or a worm gear is the gear type part. So summation of helix angle of the worm and helix angle of a worm gear is equal to 90 degree. If we take this is alpha gear, helix angle for a gear is equal to 90 minus helix angle for a worm. This is the first formula which is we required to find out the helix angle or a spiral angle. The second formula is a lead angle. Okay, lead angle. Lead angle is denoted by the lambda, or in some books it is denoted by the delta also. So we use here lambda. The lambda is equal to alpha G. Alpha G means this helix angle of a worm gear, which is equal to 90 minus alpha W. Okay, this is second formula. The third formula is the axial pitch of worm and transverse pitch of the worm gear. Axial pitch for a worm means PA. PA is equal to P for a pitch, A for axial. Axial pitch is equal to pi into MT, where MT is a transverse module. Okay, transverse module, and MT is equal to, the formula for MT is equal to DG divided by ZG, where DG is equal to diameter of the worm gear and ZG is equal to number of teeth on a worm gear. In worm and worm wheel, this formula, remember this formula, that is dg by zg is not equal to dg by dw. For a transverse module is equal to diameter of the gear divided by number of teeth on a gear, which is not equal to diameter of the worm divided by number of teeth on a worm, because both the shape of the both the gear are different. One gear is a screw type and another gear is gear type. Therefore, only this formula is useful, that is MT is equal to transverse module is equal to diameter of the gear divided by number of teeth on a gear. Normal module, the fourth formula is equal to normal module, MN. M suffix N is equal to MTG. MTG means transverse module for a gear into cos of alpha G. Alpha is the helix angle for a gear, or it is also equal to MTW into cos of alpha W. Okay, these are the formulas for a normal module. Then next one is a lead. Lead is the, if the worm is rotated through one rotation, then how much distance it will travel in a vertical direction, it is called as the lead, and lead is equal to PA. PA is the axial pitch into N. N is equal to number of start. N is equal to number of start Okay. Then PA is equal to axial pitch, N is equal to number of start. Then next formula is velocity ratio. VR velocity ratio is equal to L divided by pi into dg. L is the lead, pi into dg. Dg is the diameter of the gear. We can write L is equal to N into PA. N is equal to number of start, P is the axial pitch. This is the formula which is used to find out the velocity ratio. Then seventh formula is pitch circle radius. Radius of the pitch circle, that is RG, means radius of the gear. Radius of the gear is equal to MTG into ZG divided by 2. MTG is a transverse module for a gear. ZG is the number of teeth on a gear divided by 2, or pitch circle radius for a worm. Pitch circle radius for a worm is equal to MTW into ZW. MTW means transverse module for a worm into number of teeth on a worm divided by 2. This is the formula for a radius of the worm. Then next, center distance. This is the most important formula in this chapter, which is always required, or in every numerical they ask to calculate the center distance. Center distance is equal to MTG, means transverse module for a gear. Transverse module for a gear divided by 2 into ZW. ZW means number of teeth on a worm divided by tan of lambda. Lambda is a lead angle plus ZZ. ZZ is equal to number of teeth on a gear. Okay. Remember this MTG formula for transverse module for a gear is calculated by using also this formula. We will solve the numerical, so we will get more clear this. Then efficiency of the worm gear. The maximum efficiency. If we want to calculate the maximum efficiency, then formula for maximum efficiency is equal to 1 minus sine of phi divided by 1 plus sine of phi, where phi is the friction angle. In numerical, they given that the coefficient of the friction, and by using this coefficient of the friction, we can calculate this phi. Okay, this is the efficiency. This is the maximum efficiency. Here one formula: when worm is driver, when the worm is used as a driver, then efficiency is equal to tan of lambda divided by tan of lambda plus phi, where lambda is the lead angle and phi is the friction angle. And when the worm gear is a driver, these both formulae are different, and which is used to calculate the efficiency. When worm is driver, then efficiency is equal to tan of lambda divided by tan of lambda plus phi, and when worm gear is a driver, then efficiency is equal to tan of lambda minus phi divided by tan of lambda. This is the two different formulae to calculate the efficiency. These efficiencies depend on which one is the driver. Okay. Then 10th formula is a torque acting on a worm. The formula to calculate the torque acting on a worm, TW is a torque acting on a worm, is equal to F into sine of lambda plus phi into RW. F is the force, lambda is the lead angle, phi is the friction angle, RW is the radius of the worm. We can also calculate the torque acting on a worm gear, TG. TG is equal to F into cos of lambda plus phi into RG, where RG is the radius of the gear. These are the formulas which are required to solve the numerical. Okay. So here, these are the formulae. We will solve one numerical. So we will get more clear this idea. Okay. The first example is to start worm. Here given that to start worm means number of start of the worm is 2 rotating at 800 rpm. The speed of the worm is 800 rpm. Driven a 26 tooth worm gear means number of teeth on a worm gear is equal to 26. To start worm drives 26 number of teeth gear. Okay, the worm has pitch diameter. The pitch diameter of the worm means d of g, d of w is equal to 54 mm, and a pitch of 18 mm. Pitch of worm is given that it is 18 mm. If the coefficient of the friction is 0.06, the coefficient of the friction is 0.06, find we have to find first one is the helix angle of the worm, second one is the speed of the gear, third one is the center distance, fourth one is the lead angle for maximum efficiency, and fifth one is the efficiency and maximum efficiency. Here we have to calculate the lead angle. What is the value of lead angle for which we will get the maximum efficiency, and here they are asking the efficiency and maximum efficiency. We have to calculate the both the efficiency. Okay. Okay. And then so we will solve the numerical. The first one is a give what is given. We have given that the number of start is equal to 2. In numerical there is given that the 2 start worm means number of start n is equal to 2 rotating at 800 rpm. Speed of the worm is given that 800 rpm. Means nw is equal to 800 rpm. By using this we can calculate the angular velocity of the worm. The formula for angular velocity is equal to 2 pi n divided by 60. Nw means speed of the worm is 800 rpm divided by 60. Therefore, angular velocity of the worm is equal to 83.7758 radian per second. This is the velocity of the worm, angular velocity of the worm. Then what is given? The worm has a pitch diameter of 54 mm. The diameter of the worm is dw. Diameter of the worm is 54 mm and pitch of 18 mm. Here pitch is given, PA is equal to 18 mm. Number of teeth on a gear is given the 26. PA, axial pitch of the worm is given that 18 mm. Mu is given, coefficient of the friction is given that is 0.06. By using this we can calculate the phi, that is friction angle. Phi, tan of phi is equal to mu, therefore phi is equal to tan inverse of mu, and therefore phi is equal to 3.4336 degree. Okay, which value we have to find out? The first one is alpha w, means we have to calculate helix angle for a worm, ng speed of the gear, center distance, lambda for maximum efficiency and maximum efficiency. So we will solve this one by one. First step is to calculate the helix angle of the worm. We have to calculate the helix angle for the worm. Helix angle of the worm. We have a formula that tan of lambda is equal to n into PA divided by pi into dw. Here, if you see, here I By mistake, right? This is the n. This is not the mu. This is the n. N is the number of start. Okay. Into PA. PA is the axial pitch divided by pi into dW. dW is the diameter of the worm. Diameter of the worm. Number of start is 2. PA is the axial pitch is 18. Pi d into number of teeth on a worm, that is 54. And by using this, we can get tan of lambda is equal to 0.2122. If we take the inverse of this, we will get the lambda, and lambda is equal to 11.9804 degree. Lambda is the helix angle. Okay. Sorry, lambda is the lead angle, and lead angle is equal to helix angle of the gear. Lambda is the lead angle, and lead angle is equal to helix angle of the gear, and which is also equal to 11.9804. Okay. So by using this value, we can calculate the helix angle for the worm. Helix angle for a worm. Helix angle for a worm, that is alpha W. Alpha W is equal to 90 minus alpha G, that is 90 minus 11.9804. Helix angle or a spiral angle for a worm is equal to 78.0196. Okay, this is the helix angle for a worm. This is the first step. In first step, they ask to the helix angle of the worm, and by using this, here we calculate the helix angle of the worm, and helix angle of the worm is 78.0196. The second one is to calculate the speed of the worm. We have to calculate the speed of the worm. Gear ratio G is equal to speed of the worm divided by speed of the gear. Here we know that the worm is small in size and gear is large in size. Therefore, the speed of the worm is more and speed of the gear is less. Therefore, NW divided by NG is equal to ZG divided by ZW. Okay. Now, speed of the worm is 800 RPM. We have to calculate the speed of the gear. The number of teeth on a gear is 26. Number of teeth on a worm, that is 2. Here we take the 2 start. Our worm is just 2 start. Therefore, we take the number of teeth on a worm is equal to 2. Number of teeth on a worm is equal to 2. And by using, if we take the cross multiplication, we will get speed of the gear. And here we get the speed of the gear is equal to 61.5384 RPM. If we calculate this, we will get speed. N is for speed, G for gear. The speed of the gear is equal to 61.5384 RPM. Okay, this is the first one. This is second value that we want to calculate, or that is asked in a numerical. The third one is to calculate the center distance of the worm gear drive. We have to calculate the center distance of the worm gear. Okay. The formula for center distance is equal to C is equal to MTG divided by 2, where MTG is the transverse module for a gear divided by 2 into ZW, number of teeth on a worm, divided by tan of lambda plus number of teeth on a gear. Here we have a formula. In this formula we have to calculate the center distance, but we don't know the value of transverse module for a gear. So before going to calculate the center distance, we have to calculate the transverse module for a gear, and transverse module for a gear is equal to diameter of the gear divided by number of teeth on a gear. PA, sir, PA is the axial pitch, and axial pitch is equal to pi into MT. Pi, we have know that PA is given in a numerical, that is PA is equal to, here if we see the PA is equal to 18 mm, So we put the PA is equal to 18 pi and MT. MT is a transverse module. Okay. So by using this, we can calculate MT, that is transverse module, and transverse module is equal to 5.7296 mm. 5.7296 mm. If we put this MT here, that is transverse module for a gear, divided by 2 into number of teeth on a worm divided by tan of lambda plus number of teeth on a gear. That is MTG is equal to 5.7296 divided by 2 into ZW, that is number of teeth on a worm, is equal to 2 divided by tan of lambda. Here tan of lambda is 11.94. I have by mistake write this value. Here tan of lambda in plus 26. And if we calculate this, we will get the center distance is equal to 101.4854 mm. We get value center distance is equal to 101.4854 mm. This is the center distance between worm drive. Then fourth step is to calculate the lead angle for a maximum efficiency. What is the value of lead angle? So we will get the maximum efficiency. In spiral gear, we have a condition for a maximum efficiency is that for a maximum efficiency, alpha W means helix angle for a worm is equal to theta plus phi divided by 2, where theta is the shaft angle. Shaft angle means the angle between the two shafts. Okay, plus phi divided by 2, where phi is the friction angle and theta is the shaft angle. And for a worm and worm wheel, the shaft angle is 90 degree. For worm and worm wheel, the shaft angle is 90 degree. So we can find out here. Always remember this alpha W. This alpha W is equal to 46.7168. If we see here, we already calculate alpha W and which is equal to 78. These both value are different because here we calculate alpha W for a maximum efficiency. To get a maximum efficiency, helix angle for a worm should be equal to 46.7168. But in our numerical, alpha W is 78 degree. But if we want a maximum efficiency, the alpha W should be equal to 46.7168 degree. So here alpha W is, we have calculated the alpha W, that is helix angle for a worm. We calculate the alpha G, that is helix angle for a gear, which is equal to 90 minus alpha A, alpha W. So 90 minus 46.7168, which is equal to helix angle for a worm is equal to 43.2832. And therefore lead angle, we know that alpha W, that is helix angle for a worm, is equal to lead angle, and lead angle is equal to 43.2832. This is the value of lead angle to get a maximum efficiency. If we want a maximum efficiency, our lead angle must be 43.2832 degree. Okay. And last step of our numerical is to calculate the efficiency and maximum efficiency of the drive. Okay. We have to calculate the efficiency and maximum efficiency. Always remember, in last lecture also I told that the worm and worm in worm and worm wheel, worm is always driver and worm wheel is always driven. Means input is always given to the worm and output is always obtained at a worm wheel. So when worm is driver, the formula for efficiency is equal to tan of lambda divided by tan of lambda plus phi, where lambda is the lead angle and phi is the friction angle. So which value of lambda we need to take here to get efficiency? In our numerical, the lambda is 11.9804. So we need to take this value to calculate the efficiency. So we will take the lambda is equal to 11.9804 and phi is equal to 3.4336. So we will calculate the efficiency. Efficiency is equal to 0.7696. If we take in percentage, then efficiency for such type of the worm and worm wheel is equal to 76.96. If we take the lead angle is equal to 11.9804, then we will get the efficiency is equal to 76.96. But we want also calculate the maximum efficiency. What is the value of maximum efficiency? Means what is the value of maximum efficiency we will get when lambda is equal to 98.382832. Okay. So formula for maximum efficiency is equal to 1 minus sine of phi divided by 1 plus sine of phi. Okay. If phi is the friction angle. If we put this value here, we will get that maximum efficiency is equal to 0.8869, or maximum efficiency is equal to 88.69. Means if we take lambda or lead angle equal to 43.2832, then we will get the maximum efficiency is equal to 88.69%. But if we take the lambda is equal to 11.9804, then we will get the max efficiency is equal to 76.96. This is the first numerical, or one numerical which is asked in university exam for 8 marks. Okay. So this is the numerical which is based on the worm and worm wheel. So if you have any doubt regarding this numerical, you can ask me here. So I will clear all your doubts regarding the worm and worm wheel. जर तुमचे काही डाउट्स असतील इथं वर्म अँड वर्म व्हील रिगार्डिंग न्यूमरिकल, तर तुम्ही विचारा, इथे आपण क्लिअर करू डाउट्स. आहेत कुणाचे काही डाउट्स? ओके. डाउट्स असतील याच्या रिलेटेड काही तर विचारा, तो आपण क्लिअर करू डाउट्स. नसेल तर मी मीटिंग एंड करतो. सेकंड युनिट रिलेटेड पीपीटीज आणि नोट्स त्या गुगल क्लासरूमवर शेअर केलेल्या आहेत, त्या एकदा बघा आणि काही डाउट्स असतील तर विचारा. ओके.